Hey guys, I'm Alex, and today I'm going to be solving the May 2003 Paper 2 of the higher level exam, question 9, part 2. So the question says, for positive integers k and n, let the sequence u sub k equals 1 plus 2 times negative 1 to the k over k plus 1. And so looking at this series, we can tell that it's an alternating sequence because negative 1 is going to change as it's raised to even and odd powers of k. And then it also gives us that the sum to 2n is equal to the sum of the sequence u sub k. And so part A of this question says, show that the sum of 2n is equal to the sum of 4k minus 1 over 2k times 2k plus 1 from k equals 1 to n. And so when we're looking at the sum of 2n of the series uk, and since it's alternating, we can split it into even and odd. And so in order to generate all even numbers, we're going to do the sequence of u sub 2k, because 2k generates all even numbers. And for odd, we're going to do a sequence of 2k minus 1. This expression 2k minus 1 is going to give us all odd numbers. And so when we have odd numbers, this negative 1 is going to stay negative. But when we have even numbers, this is going to become positive, changing the values. And so what I'm going to do now is substitute 2k and 2k minus 1 into this expression for u sub k in order to find the new sequences for each of these. And so this is going to give us 1 plus 2 times negative 1 2k over 2k plus 1. And so because 2k is always even, this is going to always be a positive 1. And so we can rewrite this as 3 over 2k plus 1. And so for the series u sub 2k minus 1, we're going to substitute 2k minus 1 for all values of k. And so 1 plus 2 times negative 1 to the 2k minus 1 over 2k minus 1 plus 1. And so because 2k minus 1 gives us an odd number every time, negative 1 is going to remain negative in all cases. So this is going to turn into negative 1 over 2k. And so we can rewrite this sum of 2n as the sum to n from k equals 1 of the series of the even plus the odd terms. And so now what we're going to do is use the expressions we generated here to replace this. And so now we're going to multiply by the denominators to find the common denominator in order to try to get to this expression up here. So the sum of 2n equals the sum to n from k equals 1 of 3 times 2k minus 2k plus 1 all over 2k times 2k plus 1. And so this is going to equal 6k minus 2k minus 1 over 2k times 2k plus 1. And that's the sum too. I forgot to put that. And so this is going to end up being the expression that we have and the answer, 4k minus 1 over 2k times 2k plus 1. And so this is our final step. Stop. So from the last question, our phrase for the series u sub, or the series of this sum, was the sum of n k equals 1 of 4k minus 1 over 2k times 2k plus 1. And so this question is asking us to determine whether this is going to be convergent or divergent. So basically this is asking us if there's going to be an infinite sum or if this sum is going to converge to a single integer number. And so the way I'm going to approach this is through the limit comparison test, which states that the limit of, as n approaches infinity, of a series divided by another series, if that equals a constant c, then both series either converge or diverge. And so my a sub n is 4k minus 1 over 2k minus 2k plus 1. And so now I need to find my b sub n. And so the way I'm going to do this is kind of do a simplified version of this to determine what function is going to be always greater than a sub n across all intervals. And so the way I'm going to find this is divide out all terms by k. And so first I'm going to rewrite the denominator so everything is multiplied out, and then divide each term by k. So 4 is 1 over k over 4k plus 2. And so we can compare, when you're looking at this is approximately similar to the function 1 over k because the 4's somewhat divide out and we only have 1k in the denominator. And so 1 over k is going to be my b sub n series. And so now I'm going to take the limit as n approaches infinity of a sub n over b sub n. I'm going to equal the limit as n approaches infinity of 4k minus 1 over 2k is 2k plus 1 times k over 1, since we're multiplying by the reciprocal in order to do division. And so that's going to equal the limit as n approaches infinity of 4k squared minus k over 4k squared plus 2k. And so this limit is just going to be equal to 1 because we look at the highest power k terms and each has a coefficient of 4, meaning that as it approaches infinity, the fraction is going to approach 1. And so thus both series either converge or diverge, since the limit of a sub n over b sub n equals 1. And so using the p series, we know that 1 over k is divergent. And so if 1 over k is divergent, then 4k minus 1 over 2k times 2k plus 1 is also divergent. And so that's all we have to do for this problem.